Um, I remembered earlier that I didn't actually introduce myself. So if anybody doesn't know, I'm Jake. I am the MD for Rapid Fusion. And before I get into what I'm going to talk about here, I just want to say, I think the guys, everyone in the team has done an amazing job today. And I think this would be good if we could just give a little round of applause to thank them for all their effort. Fantastic show. And now I'm going to talk a little bit about our business strategy and kind of how we go from what we've got here today and what we're showing to real world use, I guess. So the things I'm going to cover, so you've got our commercial strategy, a little bit about our roadmap, kind of the timeline for Medusa. So we've got Medusa here today. I think it looks very much production ready, but my team will disagree. And there's still a few things we need to refine and work on, but kind of what does that look like? What can we do with Medusa? What are the options? So there's, you've seen this today, but this isn't going to be the final version, and there's other versions that we can produce. And I guess some of the next steps, if anybody in the room is interested in learning a little bit more about how they could potentially implement this technology into their business. So, it's quite low with this, so much. So our commercial strategy. So I think we've kind of spoke a lot today about having a modular roadmap, right? So what does that mean? So yes, the machine's modular. We've got elements of that machine that's modular, but also the technology we're developing is modular. We've got other products in our roadmap, like our Apollo cell or our Zeus cell, which is our robot additive solutions. And the technology that's been developed in this machine is now being pulled straight into that roadmap as well. So I'll cover a little bit more about how that looks, but this is our ethos as a business. It's not to waste time just developing one piece of technology. Why not develop that technology and then implement that across your whole range overnight? So IP development is definitely something we're really keen to do, and I think we can announce that we've got 3 patents pending on this project. So as a result of the funding from Innovate UK and the team that we've all worked with and all the partners, we've managed to produce 3 patents we think that will be of massive use to us and the industry moving forward. And then funding, without Innovate UK's money and without that pot that's there and that resource and other funding resources, how do we develop IP? Well, it's quite a task really to fund all that. So it's great that we are aligned with the commercial, with the strategy of the funding pots, and that we work with those initiatives to help generate more IP for the business. And then commercialization. Great to have great IP and great technology, but if we can't sell it or can't make money from it or it doesn't help industry, then why are we doing it? So everything comes round to being commercialized. We're not going to develop things that are novel just for the sake of it. We want to develop things that solve real world problems. Let's talk a little bit about the roadmap. So we've got robotic cells, which you will see one next door that's been printing today. We've got Apollo, which is just additive only solution. Zeus, which is hybrid, so additive and subtractive. And we've got Artimus, which is CNC. This roadmap for us is staying stable. What we're going to do is we're going to take technology that we've learned from building Medusa, adding those feature sets, adding sensors, and adding more intelligent design into our products. So if you've already bought any of these products from us, which some people have, their products will get cleverer and more intelligent over time. So this is again back to that state of modular design, right? Designing technology that's modular that we can roll out across all our products. We're also, you'll know, on the machine in there, that extruder is actually taken from our extruder that we launched with Apollo earlier in last year. So again, that modular theme, we've taken existing technology, adapted it and added it to Medusa, but now we're going to add a bigger lineup to our extruder lineup. So we've got the PE420, the PE520, and we're also looking at high temperature. High temperature being those polymers that are really difficult to print with, that require localized heating. This is something in our roadmap that we want to develop over the next 12 months. So intelligent automation sounds fancy, doesn't it? What does it mean? So I think we can all see next door, we've got a thermal imaging camera. That thermal imaging camera is just a camera that shows you thermals, right? But with the loop that we get from actually taking that data, adapting our toolpath and changing what we're doing and learning from that print, that gives us intelligent automation. It makes our prints more successful first time round. Topology bed mesh, it's quite a fancy word as well. I think I'll thank Joel for that, throwing that one in. But we're talking about bed mesh leveling, right? So at the moment, it crazy as it sounds, in robotics printing, it doesn't exist. You know, people aren't actually using that. So your first layer is a bit of a guess, really. You're kind of taking some data points, saying that's level, and then printing. So we're adding stuff we've learned from Medusa. This is all new technology that doesn't exist in the market currently for this type of technology. Defect detection. We've, you know, as Martin said, we've loaded this machine with unbelievable cameras and sensors that cost lots of money for us to be hardware loaded so that we can then add software later on that gives us data back to be able to do stuff on the fly with our prints. And we've already enabled some of that technology already, and there'll be more announcements around what we can do. But this is going to be heavily then loaded into the next topic, which is AI. So for us, I think we'll see a massive increase in AI language models. We want to build a model that helps your printer get intelligent over time, right? So why not be putting your data back into your machine to learn from consistently to then improve what the outcomes are? So this is part of our roadmap. And then Medusa. So I think it looks fantastic and you can see the capability. What we wanted to do is build something that, you know, showed you what is capable with this machine and give you a real flavor of what it looks like. But then there's lots of things we can do. Being modular, we can increase the size of the machine. So you've got kind of your two ends, which are control module, and the other end has, you know, drying and pellet feeding and etc. on the one side. But the bit in between can be extended, made longer, wider. You know, that motion system can be as big as you need it to be. You know, there's nothing to stop us doing meters by meters and having the same functionality. So, you know, open your mind up to the idea of, okay, I don't need a meter by meter. I might need half a meter by 4 meters long. That's possible with this system. And very little redevelopment for us to do that. Additional tool heads. So we're looking at, as I mentioned before, higher deposition rates with bigger extruders. Again, nothing to stop us adding that modular product into the lineup and adding that to the machine. But things like also high temperature, additional axes, and scanning as well being a feature that we can add. So I think there's, you know, what we want people to do today is have a think about what you need as a business, where you go, what's your requirement, and where can we build something that makes and meets that requirement or exceeds it, hopefully. So what does timeline look like? So we're saying, right, the next quarter, it's going to be testing and refinement. We're going to be spending a lot of time putting it through its paces, making sure that it delivers what we think it should, and obviously learning from what we've done and what we've built. And then in time, we'll go to beta test unit. So we want to ship a unit out. We want to put it into someone's business. You know, we want to make sure that it's in the real world, being used for real world applications. And then from that, we can also learn and adapt from that. And then we're looking at Q4. We want to go into a pre-production model. And that pre-production model is going to be pretty much bang on, right, at that point. And then Q1 of next year, so 2026, we want to go into production. So this is our ambitious roadmap. But I think considering we've taken probably just about of this time to develop it from scratch to building it today, I think it's probably possible that this would be met. So what are the next steps? We are actively engaging with people. Some of you in the room will know who you are, but we're looking at funding with partners. You know, we want to go after more pots of funding to develop the roadmap further, to keep aligning with the organisations like Innovate UK, and developing an IP and technology that helps the whole industry grow. We're also looking for that beta partnership. So, you know, again, it's important that we align with someone that we can put this product into and get real world feedback from. And then pilot projects, there's nothing to stop you even on any of the technology you've seen today. If your business is at that early adoption stage where you're looking into whether you want to take this technology and use it in-house, work with us on a pilot project. Our team are really knowledgeable. They'll help you through every step. We can help redesign the parts if needed, print them, get you the feedback loop that you need or the data you need to make an informed decision on your CapEx spend or OpEx spend. So now you'll be thankful to know that is it. There's no more presentations. The bar is open. Food will be served shortly. And I want to thank you all for coming, and I hope you have an amazing day. Safe travels back.